All right, let's write a simple program in Clipper to get started with our compiler. And all we're going to do in this program is assign a number to a variable, and then we're going to use that variable to set the exit code, and then we're going to see if that exit code is properly set, right? In MS-DOS, the exit code is actually called error level. So we're going to set that error level, and then we're going to see if the error level was set, right? And then when we're compiling this to Linux, what we're going to do is set the exit code that we are, acquainted with. So let's do vim exit code.prg. And then we're going to do numeric variable 1 is going to take value 2. And then we're going to call the error level function from Clipper to envar1. And that's going to hopefully set the error level that we can check with an if statement afterwards. So let's go ahead and compile this. Link it. And here we're going to speed up the CPU. There we go. So now if I do exit code, nothing happens. But if I do this, if error level 3, echo high, you see that nothing happens. But if I do if error level 2, you can see that it says high. And the way that the error level works, even if I check for 1, it's going to be set like that, right? So this is the program that I want to replicate in our compiler. So let's create a new Rust project. So let's do cargo new YAL. Let's go into YAL, and let's open new vim. There we go. And let's add a README here. So the name of our language is going to be YAL. And the reason I chose YAL is because Clipper, if you look on Wikipedia, it was this kind of ship from the 1800s, right? And then I was looking for some synonymous of Clipper or things that are related to Clipper, and I found that there was another ship called, another kind of ship, it's more of a boat, called YAL. And so here it is, right? So that's the idea behind the name, this kind of boat here. And also because YAL is a very nice word to use as an acronym, right? So we can call it this yet another, I don't know, weird language, or we can use something else for the W. If you have any ideas or suggestions, make sure you leave a comment. I'm open to changing this to something else. All right, now that we have that out of the way, let's go back and go to main. And the first thing that we want to do is to have the example program here. So let's do let program. It's going to be this, and then the same thing that we did there, and var1. Yeah, and this is how you assign a variable in Clipper, is colon equals. And let's assign this to 2. Was it 2 that I used on the other one? Let me see. Error level PRG. No, it's exit code. Exit code PRG. Yeah, we used 2, so we're going to do the same thing. And then we're going to call error level with envar1, like that. Okay, and then in order to start working on it, the first thing that we need to do is to start lexing this thing, right? So lexing is breaking the textual form of the program into tokens, right? You see what I mean as we go through this. So let's go ahead and create a lexer. So we're going to say let lexer equals lexer new. Let me turn off copilot disable. There we go. And then we're going to pass in the program. And then we're probably going to say let tokens is lexer dot tokenize, and that we return like a vector of tokens, right? Let's go ahead and create our lexer, and the lexer is going to hold the source for our program, and I don't want to copy it, so we're going to have a reference to stir, and that is going to make us have a lifetime like that. And then we're going to need a position on where we are in the source code, and that's going to be a usize. All right, let's implement new and tokenize. So let's go ahead and implement lexer. Let's do pub function new, and we're going to take a source that's going to be a pointer to the program, so a stir. And then here we're going to return a lexer. And then here all we have to do is self, source, and then pause 0. And then for the tokenize, we're going to have self, and we're going to return a vector of tokens. So we're going to have an enum token. And if we take a look at our program here, what are the things that we need? We need a variable name. So this is going to be an identifier on the language. We need to have this assignment thing, which we can call colon equals. And then we're going to have constants. In this case, it's going to be an integer constant, so int. Error level is also going to be another identifier. Then we're going to have open parents. Then this is another identifier, and close parents. All right, so from what I think I saw here, we'll need an identifier that takes a string. We'll also need an int that takes an i32. We need colon equals, open parents, and close parents, right? Okay, and then in order to tokenize, all we need to do is to start walking through the program and figuring out if it matches any of the tokens. So we're going to do while pause less than self.source.len, right? We're gonna, and now what we need to do is to, for every part that we are on the source code, we need to see if it matches one of the tokens. In order to do that, if we wanted to do everything by hand, what we needed to do was to start implementing token. And then we probably could have something like a function called regex, for lack of a better term, for self that returns a regex, right? Actually, an optional. Oops. And then we would need to do something like match self. If we were an identifier, it would be something like, so let's add regex. And then identifier is going to return something like, so the variables in Clipper, I think it can start with any alphanumeric, not alphanumeric, any alpha characters. So let's do A to Z, A to Z. I think underscore is also allowed. And then that's the starting character. Then after that, we can do A to Z, 0 to 9, and underscore, then any number of those. So this would be our, and then that's not a regex, that's a string actually, right? This would return sum, like this. And then for now, what we can do, if we take something else, we're going to call it to do, right? And then you would have to do this, somewhat like this. Right, what I'm thinking of doing instead, before that. And another thing we would need to do is to do an iterator. So we would need to think, can we implement iterator for token? Then the type of iterating would be a token. And then the next, we would have to keep something, some state, because I want to iterate like this, right? But instead of going down this route, what I really wanted to do is to use this array called strum. So we can do strum macros like this. And then we can not do it like this. What we can actually do is here, we're gonna derive on debug clone, and then we're going to derive on enum property or something like that. Let me see. Docs.rs strum. Yeah, enum property. So that was correct. And actually, the one that we want is from strum macros, I think. And what this is going to allow us to do is to go here and do strum prop, then regex equals 2. Then edit here, like that. Props. There we go. And then here, instead of doing it this way, what we can do is simply do self.getStir. And then the name of the property is going to be regex. And boom. Now we have the same thing, but done for us. All right. And another thing that this crate has is the ability to iterate on enum variants. So if I do enum iter here, that's going to give us token iter, and for token in token.iter, we can do then let re equals token.regex if some can go like this, then let re equals to regex new re, and then we can do if let sum captures equals to re dot cap dot, let's import it, captures, and then we can do self dot source, and then starting from the self pause to see if it matches. Let's see what's wrong here. Let's do a to do. Do we need this? I think that's the problem. And then now we have a regex. Then we have to borrow this guy. Okay. Yeah, and then here, this has to be self.pause. I think we need to import, strum macros, enum iter here. Let's see if it now recognizes iter. Yep, there we go. Okay, can only be used, yes. So now we need to also add anyhow, so we can start throwing errors. Okay, and then this is gonna be anyhow, oops. It's gonna be anyhow result vector, oh my God. Result vec token, just like that. We might need to borrow here. Okay, sounds good. And then if that's a match, what we'll do, let matched equals to caps get 0 unwrap, because we know it matched. So this is going to give us everything that was captured. And then we can do like self.pause matched len, so we advance everything that matched. And now tokens.push, so the token that matched is going to be token. We don't have tokens, so let's do let mute tokens is vec new. With that, we can return down here the tokens. Cannot assign. Okay, yeah, let's start making this guy a mutable reference. And then this guy is going to have to be mutable. All right, let's print tokens. Then we're going to do for token in tokens. We're going to do and print it here. Let's do tokens like this. Actually, token. And then let's see here. Mm-hmm. Yeah, and then I think this is when in a state that we can start to run it. So let me go here and do cargo run. We have to go into y'all. Let's see what we get. Expected option string because of return type. So the get stir thing, we're probably gonna have to do cloned like that. So we gotta stir. Okay, we can do a stir. And we don't need to clone. And everybody's in love with it. Everybody's happy, so we no longer need to do this. Very good. Let's see what we get now. If we go here. So you can see that it's locked. It's freezing because, let's see. Oh, because if it doesn't match, we don't do anything, right? So what we actually need to do is to do let mute found equals false. And then here, when we recognize something, we're going to do found true, right? And then here at the end, if not found, we're going to throw an error. So anyhow, bail, unexpected token. And then we can let the user know which token we'd match that we didn't expect. And actually here, what we need to do is to put self.source, self.pause, so we get the point where we are while parsing. Okay. So we need to do it like this. There we go. Let's see what we get now. Something's not right. Let's see. While the pause is less than source.len. Yeah, I expect this to trigger. Let's see. Okay, so it did this like 6 times. Okay, so we are always in this. Let's see, match it. Oh, so this is a match. Stir, maybe. Okay, so it matched. I know it's wrong. Yeah, it's gonna match this. We need to make sure that the beginning of the string is matched. Let's do this. Okay, it's a little bit better, but still is not doing what I expected it to do. Let's see. So found is false. Did we get into matched? No. So I would expect this to be false. Yeah, found is false. Why is it not returning this error here? Oh, this is why. We are swallowing the error. So let's make sure that we resort like that. Let's do OK. Let's try again. There we go, unexpected token. And I expected this to happen because what's actually happening is it's trying to match the spaces, right? So what we need to do here is to do self dot skip white spaces. Let's create this method here. It's going to be function skip white spaces. Then we're going to do a loop where we increment. So let's see. Let ch is going to be self. Oh, mute self. It's going to be self dot source dot chars dot nth self dot pause dot so if if we in that position we do have a character, what we're going to do is if not ch dot is white space, we're going to break, right? And if we didn't find any characters, we're going to break as well. And then we're going to do self.pause, increment the position, and I think we should be almost there. Let's see. What's the problem here? This loop could be written as a white violet. So let's see, while, I like it. While let, then we don't need this. All right, so while we have a character, if it's not a white space, we're going to break. Otherwise, we're going to advance the position. Okay, so we can see that we now matched nvar1. So we need to do the same for the other stuff. So let's go here. Strum props regex is going to be same thing here, except that we want 0, 9 and 1 or more times like that. This one is going to be super easy because the regex is going to be the literal thing. So colon equals open parens is going to be strum, same thing, props regex is going to be this, and then we need to escape the open parens like this, and we can actually copy and paste this guy, but instead here we want to close parens. There we go. Let's see. So I think we might not need this because of the R. There we go. At the end, we got an unexpected token, but let's see. I think we matched everything. I know what the problem is. Here, we cannot go through the token thing if we are. So if self.pause is more or equals to self source len, we need to break. Let's try now. And there you have it. You can see that we have the identifier, the colon equal. So if we take a look at our program here, so we have the identifier, the colon equal, and the int, right? Then we have an identifier, open parens, another identifier, and close parens. The only thing that I think is missing here is to properly fill the name of the identifier and the value of the int. And that can be done by just doing this. Let token equals match token. And then we're going to do token identifier. And we don't care what comes in because it's probably the empty string. And we're going to map it to token identifier with what we matched, then to string. Same thing for the int, where we're going to disregard the 0. And instead, we're going to get an int from the matched dot parse dot unwrap. And we can do unwrap here because we know that if it's an int, it matched only the number characters or numeric characters. All right. So if it's anything else, if it's any other token, we just return it as is. And with that, I think we might have it all. Yep, there we go. So looking at this again, we have a identifier, an identifier called nvar1. Then we have the colon equal. Then we have an integer of value 2. Then we have another identifier, error level, open parens, nvar1, and close parens. So there we have it. Now, before we move to the next step, which is to parse the tokens, let's do a little bit of cleanup here. Let's create a new file called Lexer. And let's get everything related to the Lexer and move it to Lexer along with this stuff. And let's do it mod. And then let's see here. Yeah, Lexer is probably not public. Let's make it public like that. Then if we save this, we can import Lexer. Oh, and tokenize. Oh, the token is not. So let's go to the token and let's make it public. There we go. So if I did this correctly, we should still be running. There we go. And now the next step is to write our parser. So for the parser, we're going to do something very similar to what we did for the Lexer. We're going to do let parser equals parser new, and it's going to take the tokens, and it's going to give us an AST when we do parser.parse, like that. So let's create our struct parser. And this guy, I think, also is going to have a lifetime of A, because we also want to keep the source on the parser and the list of tokens. Like this. I don't know if we really need the source, I'm thinking here. Let's leave it without the list of tokens for now. And instead, we're going to pass in the tokens like that. Let's create the new method, pub new, and then token is going to be a token. We're going to return a parser of A. This is going to be self token. It's actually tokens, right? Tokens. Oops, just like this. Here we go. And then let's implement parse. That's going to return a result of our AST. We don't know yet. Let's do a to-do here. And then if you take a look at our program here, what we really have is, so let's declare a program. So struct program. And later on, the program will have multiple functions and whatnot, but for the time being, I think all we have on the program is a list of statements, right? So the program is going to have statements, and statements are going to be a vector of statement, like so. So let's create our statements. Okay. So on the first line here, we have a variable assignment, right? So we are basically assigning a constant to a variable. So I think all of those are expressions. So the only thing we're going to have as a statement is an expression, and it's going to have an exp. So we can declare our new exp, and then we're going to have constant. And for the time being, a constant can only be a i32 because we only support ints. What else can it be? A variable assignment, a variable that has a name. I'm going to even put it here. So variable constant. Then we have assignment. And the assignment takes an expression on the left-hand side. I think so. So it's going to be a box of expression and a box of expression here. To make this a little simpler, I think we can get start only accepting a var on the left-hand side. And then we can make this a little more. Oh, but a var is also an expression. Yeah, so never mind. Okay. And then finally, we have the function call. The function call has a name and a vector of expression as the arguments, right? There we go. Okay, so now what we need to do is to start parsing the program. So I think what we can do is start with a mutable list of statements like this. And then let's think. While self.peak token is sum. And then we have to do fn peak token. Self is going to return a token, option token, like this. And then we're going to get self.tokens get 0. Let's see. Expected because of return type. Oh yeah, cloned is fine. Okay. All right. And then while we have something, what we want to do is to statements.push self.parse statement like this. Yeah. And then here we can do OK statements. Actually, OK. And then here what we're going to do is return a program. We can do program new with the statements. Then where's our program here? Let's do a implement program and public function new, and we're going to take a list of statements, which is a vec statement, and we're going to return self or program to follow what we've been doing. And then self statements. There we go. So now we have to implement parse statement. Self. Okay, let's think about this. So up to now, our statements can only be two things really, right? If we go here, it can either be an assignment or a function call. And the way that we can make this work is we do let name, either the name of the variable or the name of the function is going to be gathered by self.parse identifier, like this, and then this is going to return anyhow result statement, right? We can have parse identifier self anyhow result string, and then here we have to do this let some token identifier equals self dot next token. Let else we can say anyhow bail expected identifier found, and then self dot peak token like this. Yeah, so now identifier should be a string, and we can return the identifier like that. So we need to implement next token, and now I think we need to make everything here mutable, because we're going to have to do the following. Let token equals self.peak token to get the next token, and then we're going to do self.tokens equals self.tokens 1 onwards, right? And then we're going to return token. Like that. I think that's correct. So that's going to make this be mutable. I'm pretty sure this also is going to be mutable. Same here. will have to be mutable. And finally, our parser has to be mutable. There we go. Okay, so now we have the name of the function or variable. So we need to check if self.peak token is a token, what's the name, colon equal. We know it's a variable assignment. So we're going to do self.parse assignment. And then we need to pass in the name of the variable we're assigning. Else if self.peak token equals token open parens, we're going to do self.parse function call with the name, right? Oh, hold on, but what we were saying is that the statement is going to have an yeah, that's right. So parse statement is the only thing it's going to do. Let me create another function here called parse expression. And this is going to also take mute self and return anyhow result expression. And this guy, the only thing it's going to really do is, okay, statement expression self.parse exp like this. Right. So we're going to have to do this. Let expression equals to this. Or maybe not. I think we have to do it. So let's keep it. And then if it's not one of those two, we need to anyhow bail. And then say expected expression found. And then we're going to have self.peak token. There we go. Let's add, and then, okay, expression, okay, expression like this. All right, then function parse assignment, and then we're going to do mute self, and the name of the assignment, so for our name, it's going to be string, and we're going to return anyhow result of expression. In this case, it's going to be an assignment, so we already know the var name. We're just missing the expression here, and this is expression assignment. And then let exp equals self.parse expression, right? Yes, and then not this. Let's see, what do we have in assignment? So assignment is a yeah, that's right. So it's going to be let var equals expression var name like this. And then we have box new var. Let's just make this name. And then here like that. And I think we're good. Binary operation. Okay, so in token, what we have to do is add partial EQ so we can compare them. There we go. And then, yes, this has to be sum. And same here. Okay. Yeah. Perfect. Now, yeah, and I think if we need to do the function call. Parse fun call, mute self, name string, and we return the same thing, result, expression. And then let me see what the function call has. A string and a vector of parameters. Okay, let's try to parse that. So now we are at the open parens of the function call. So we can do the following: self.expect token open parens. And then we can create that method. Expect, then mute self, and we expect, I don't think this needs to be mutable. And then a token. Let's call it expected. Then what we can do is let token equals or actual is self.take token, like this. And then let sum actual equals to this. Otherwise, we can say anyhow bail expected found end of file, or something like this. And this, of course, needs to return a result. Okay. And then here we consume the token. Is there a problem here? Okay. And then if matches, yes, actual and expected and actual. It's kind of weird to use it like this. There's another peak token with a similar name. Oh, it's not take token, it's next token. We actually gonna need, I think, a take token, but we'll do it when we need it. So the expected and the actual, if they don't match, we're gonna do anyhow bail expected found actual, like this. And then return, not return, just an okay here. Okay, what's the issue? Next token mutates it. So yes, this needs to be mutable. Move occurs because expected has type. Okay. Why is that? And I think we can do straight equality. So if actual not equals to expected. There we go. Okay. What's the issue here? Yeah. This. All right. So we expect the open parens. We consume it, and now we need to start iterating on the arguments. It's a function call. Those are arguments. So let's do let mute args vec new. And then what we're going to do is we're going to do a loop and args dot push self dot, let me see. Oh yeah, we need expressions. Self dot parse expression, like this. And then if self dot peak token is some token close parens, we exit. And then here's where we consume the close parens, self dot take token. And then we return exp fun call name and args, like this. Let's see. This is not exit. This is break. Yeah, so take token. Let's add it here. This one is mutable as well, but I don't think it returns anything. The only thing that it does is this. So here we can do self.take token. We can actually return it, right? Yeah, let's return it. No, that's fine. Take token just skips one. It's fine. Yeah, this can. If self dot tokens dot len is less than 1, anyhow, bail, premature end of file for now. All right, and then we skip the close brands, and we have a function call. If we try to run it now, oh, hold on, we still have errors. Let's see here. Contains okay, because probably this needs to go like that. And now we're good. I expect that this is not going to work because on the parse expression, we're not parsing the other possible expressions, which is variable and constant. We are just parsing assignment and function call. But let's take a look. So if I do cargo run, still have errors. So let me check the errors. Oh, here it is. Borrow of, yeah. Here we need to do this. There we go. Let's see now. So we had also a warning. Let me see the warning that we had. So this is fine. Let's do this. Print ln ast. And then here we can do a print. And then we're going to do for statement in. And this is no longer ast. This is program. Program dot statements. And then we're going to do a print ln statement like so. One of the expressions has a few of the same name on rep. There. Let's see. What's the issue here? Oh, I did st. Yep, statement. So we need a whole lot. So let's do statement. This guy, let's add clone. Not clone. Derive, debug, clone, just like that. Let's copy this, paste it everywhere. Okay. Self tokens first. I like that. There we go. Cloned is empty, is fine with me as well. Is empty. Good catch. Take token needs this. This function returns an option. What is the issue here? Take token. Oh, yeah. Hold on. Take token. Oh, if take token can fail, then this can fail, which is fine. And yes, here we need a try. And now, let's see. Here we need that as well. Oops. There we go. Yeah, those are things that are not being used, which I'm fine with. Let's see if now we can run this. Yeah, so this is exactly what I was expecting to happen. Expected identifier found some int 2. Because of course, we are not handling ints, we're not handling constants, and we're not handling variables. So let's add those. So here, I think we can actually, no, not really. So else if self.pick token is some token int, what we can do is self.parse int. Oh, but hold on, we don't want to. Yeah, if it's a function call, that's right. Thinking here. So So I'm starting to think that we actually want this here, right? If self.peak token is some token identifier, even better, if let some token identifier name equals self.peak token, nice. We don't need to do the let name anymore. And then we can take this out and expected expression after expected colon equals or open parens after identifier, but found that. Very good. So here we need to self.take token consumes the identifier. Then if it's colon equals, we're going to parse assignment. There we go. Parse call name. Yeah, so should we return it here? Don't know. Let's see. And then if it's not an identifier, what we should have is either int or var. So let's do match. You know what? Should we match? Yeah. This way we're going to have the catch all the different branches. So let's do let exp is a match of self peak token. And then if it's some token identifier name, what we do is this here. Yeah, so let's do it like this. And then we do all of this and we put it here. And then, yeah, to be honest, this doesn't make that lot of changes because we're still not going to handle all the tokens, right? So, but anyways, let's continue down this path. Some token, which is the one that we int, and then the number like this. What we're going to do is an expression constant n, right? And then if it's some token var name, is it var? Oh no, hold on. Let's see here. No, it's not variable. So let's see. We have var, we have constant, we have assignment, and we have function call. So we were just missing constant. Hold on, var. So we have assignment and function call. We need var. Yeah, we do need var. But the var is going to be on this case here. No, that's an assignment. That's right. No, I think that's it. Let's test this. We don't need this anymore, at least for now. Yep, we don't need this here. This is found to be of type. So, yeah, we don't need this anymore. There we go. Okay. Non-exhaustive, yes. So if we get none, what we do is anyhow bail expected expression found end of file. Yeah, now we have exp, and bail. What if we return? Is that okay? Oh, then all that it was? Let's see. Ensure that all possible cases. Yes. So we are still missing quite a few. And to be, yeah, so if we have some token, we can have a separate case here that says anyhow, bail, expected expression, found token. There we go. Take token, takes a question mark. Let's see what we get now. Expected expression found, colon equal. Really? I thought, okay, let's see here. Parse expression, and then let's do like this, self pick token. Identifier and var, colon equal. Where is parse assignment? Yeah, true. We need to expect for the token colon equal on the assignment. Now we're doing something wrong. We're doing parse exp forever. Let me think. So we're not advancing somewhere. Parse expression. That's going to fall into, oh, this is peak token. Should it be take token? Or next token? I think so. Yeah, I like that better. Self expect also needs this. Let's see now. Okay, so it parsed an identifier, the int2, nice, the error level, and var. Yeah, if it's not something else. Found close parent. So yeah, the function call here. We are not taking the, are we? I thought we were here. So we break when we see close parents and expect token close parents. Is that gonna do it? I don't think so. Why? Where is this happening? It's happening here. So we did identifier var1. Is it just an identifier? Let's see what happens if I, because it can be a variable, right? Let's do this, self.parse. We don't need to parse variable. What we can do, if we're assuming that this is a variable, we can do exp var name, like this. Let's see. Yeah, I think, at least for the current program, we are seeing what I expected to see. So we have two expressions, one assignment to the variable nvar1, the constant 2, and then we have a function call to the error level function with only one argument, that is nvar1 as a variable. I like this very much. All right, this is going to be it for this episode. And I think after this, what we're going to do is we're going to start to try to assemble this in a way that we can emit a program that runs and returns that exit code the same way we did that for the DOS program here, right? All right. Thank you guys for watching, and I'll see you on the next one. Bye-bye.